This is day 18 of Unit 7. We started today with this warm-up, so pause the video and try the warm-up, and then play to check your answers. So first one, we're solving for x, so add 1, divide by 2, simplify 1/2 y plus 1/2 equals x squared, square root. Square root of an x squared is the absolute value of x. Hopefully you remembered that. And interchange, well, first of all, make that plus minus. And interchange x and y. And this was f of x, so I'm going to make that f inverse of x. And that is my equation. Then page 5, the first problem. So it's similar to that one we just did. So f of x equals negative 2x squared plus 7. So I subtract 7, divide by negative 2. So negative 1/2 y plus 7/2. And then square root. Square root of x squared is absolute value of x. And make my answer plus or minus. And then interchange x and y and make that f inverse of x. And that's my equation for the inverse. Okay. So then we just continued on with problem 2 on page 5. So we have our g of x equals square root of x minus 4. So I asked students to just try that. Find the inverse. Take a moment, try that. So hopefully you realize we need to square both sides, which gives me x minus 4 equals y squared. And then add 4. And interchange x with y and rewrite that as g inverse of x. Okay. So that is our inverse. Now we have to decide if that, or we're going to look at the graph and we're going to decide if that matches up with our graph. I will tell you, we're going to come back to this equation because we need to alter it just slightly. But for right now, based on the algebra, that's correct so far. But now we're going to take a look at the table and the graph. So I asked for a table for x and g of x in part 3. So just figure out some values that you can substitute in easily into g of x. So hopefully you're realizing 4 would be nice. Square root of 0 is 0. So then 5. Square root of 1 is 1, and 8 would give me square root of 4, which is 2, and 13, square root of 9, which is 3. So I'm going to plot those. So 4, 0. Now, before I even plot those, we know what the square root of x minus 4 looks like. We graphed those a couple weeks ago, earlier in the unit. So we know square root, a positive square root looks like half of a parabola, the positive half that's on its side. So we're going to expect to see that when we plot these points. 5, 1 is right here. 8, 2, right there, and 13, 3, right about there. So we get what we expected, parabola on its side, only half of the parabola, the positive half. So that is our g of x. Now, we also talked about last week that once we have the points of a graph, we can flip those to get the inverse points, or the points of the inverse graph, rather than using the equation. So let's do that. Let's take each one of these points and flip them, or reverse the x and the y. That gives me 0, 4, 1, 5, 2, 8, and 3, 13. And I'm going to plot those as well. So 0, 4, right there, 1, 5, right there, 2, 8, right there, and 3, 13. I'm just going to eyeball that one right about there. So then there's my inverse graph. So I'm going to call that G inverse of x. Okay, now that looks right because I know that the original is folded across the line y equals x, and it looks like that is what I would get when I fold that half of a parabola on its side. If I fold that over line y equals x, I would get half of a parabola. So now I have to go back and make sure that my equation for the inverse matches my graph for the inverse. And so I'm looking at this equation, and I know that this equation, y equals x squared plus 4, that's a parabola shifted 4 up. So I do have a parabola shifted 4 up, but I only have the positive half. And my equation says the whole parabola. So we're realizing that because the original graph was only half of a parabola on its side, and then the inverse graph is only going to be half of a parabola. So even though I did the algebra correct, I'm going to have to restrict the domain here of this equation so that the equation and the inverse graph match. Right now they don't. So I know that I'm going to put x, and I'm going to have to figure out what the restriction is. Well, I want x to be at this vertex and to the right of that. Well, the vertex is at x equals 0, and to the right of that would be greater. So my domain restriction is x is greater than or equal to 0. Now, the fact that I've added that domain restriction, now my inverse equation and my inverse graph match. So now I'm finished. Okay, now you're probably thinking, well, we never had to check the graphs before to make sure that the inverse graph matched the inverse equation. True. All the ones we did so far were odd powers and odd roots, or they were just linear, or we did the rationals. This is the first time we're having to check to make sure that the inverse graph and equation match, because this is the first time we've looked at even roots and even powers. And if you recall, all year when we've done things with even roots and even powers, there were restrictions and things that were different because of the evens. We had to include absolute value when we were talking about simplifying radicals that had even roots. So there's all along been something different about even roots and even powers. Same thing here. When we solved radical equations and we had to check for extraneous, remember we had to check for the even ones, even roots. So once again, the ones with the even roots or the even powers are the ones where you have to check to see that the graph and the inverse equation match. If it's anything else besides even roots or even powers, you don't have to check to make sure the graph and equation match, because they will. So that takes care of parts 2 and 3. Let's take a look at 4. So for A, I'm going to look at the equation first, and I'm going to decide, just looking at the equation, whether I'm going to need a restriction on this one or not. Well, I have plus or minus the square root. So I know plus or minus the square root. I'm just going to draw myself a quick sketch here. And it doesn't have to be like a perfect graph or anything. All I need to know is what the graph kind of generally looks like. And so I know that it's going to be a full parabola on its side, and I know that because it's a square root and because it's plus or minus. So then if I take that parabola on its side and I flip it across the line y equals x, I'm going to get a full parabola. So if I get a full parabola, then there is no need for a restriction on this. So basically what that means is, because I'm going from a full to a full, I'm going to just go right through the algebraic approach, and I will not have to do anything extra. No restriction required. So I'm going to go ahead and solve this. So I'm going to square both sides to get rid of that square root. And also, when I square both sides, I'm squaring that positive or negative. Students always get confused by that. Don't. If I take a positive and I square it, I get a positive. If I take a negative and I square it, I get a positive. So the plus minus is going away when we square, and we're just left with what was underneath the square root in the first place. So now I'm going to subtract 1 and divide by 3. So y squared minus 1 over 3 equals x. I guess I could simplify that to 1/3 y squared minus 1/3 equals x, and interchange x and y, and this one was just y equals to begin with, so no need to write f inverse. So just y equals 1/3 x squared minus 1/3. Now again, we said original was a parabola on its side, inverse is a parabola. That's exactly what I'm getting, a full parabola, which is what I want. I do not restrict the domain on that. B. So I have y equals 1/2 times the quantity x plus 4 squared plus 1, but there's a domain restriction. So that really is going to affect my graph. So I might as well plot myself or give myself a little sketch. So I know that without the restriction, this is a full parabola. Plus 4 I know is left 4, and plus 1 is up 1. So -4, 1 is the vertex. I know that. And then it says that x is less than or equal to -4. Well, less than or equal to, here's my vertex, less than or equal to -4 means to the left. So I know that it's just going to be a parabola the left-hand side only because of that domain restriction. So I'm going to take that point, -4, 1, and I'm going to flip it. So 1, -4, and I'm going to plot that point. And now I'm going to think, if I take this left side of a parabola and I flip it across the line, y equals x, I am going to get the bottom part of the parabola that's on its side. So 1, -4, we have that vertex there. We know it's going to be the bottom piece of the parabola on its side. An easy way to remember that is if you start with the negative part of the parabola, you're going to end with the negative part of the parabola on its side. If you start with the positive part of the parabola, you're going to end with the positive part of the parabola on its side. So right side of the parabola means top of the parabola on its side, and left side of the parabola means bottom part of the parabola on its side. So now we have those matching. So this one, because I started with an equation for a full parabola, but because we had a domain restriction, now when I solve algebraically, I am going to get a full parabola on its side, which I don't want because I only want the bottom piece. So in this one, I am going to have to restrict the domain. So let's see if we can figure out how to do that. So I'm going to go ahead and solve this. So subtracting 1. Next, we're going to multiply by 2. So I'm going to distribute the 2 here. 2y minus 2 equals x plus 4, the quantity squared. I'm trying to undo squaring, so square root. Square root of something being squared is the absolute value. To get rid of the absolute value, make my answer plus or minus. Subtract 4. And interchange x and y. And this one was just y equals, so I'm going to keep it y equals. So now this one, we had a domain restriction on the original, which means we'll have a range restriction on the inverse. So that's one way you can think about it. Or domain restriction becomes the range domain restriction on the original becomes the range restriction on the inverse. Other way to think of it, I think it's easier if you just look at the graph or the sketch. So we already know this is what we want. We want that bottom piece of the parabola that's on its side. So I'm looking at this equation. That plus minus means both the top and the bottom. Well, we don't want both the top and the bottom. We already figured out that we want just the bottom. So the piece that we want is the negative piece. So all I have to do is just get rid of the plus piece and only include the negative in my answer. So -4 minus the square root of 2x minus 2 is equal to y. That is our inverse equation. And now that corresponds and matches with our sketch. Okay, so we have just the negative piece. So now that's correct. Letter C. So we have h of x equals negative square root of x minus 2, and then plus 6. Now again, start by thinking of the sketch, or making a sketch, thinking what the graph looks like. So I know negative square root, that's similar to this one, what the inverse was. So that's what our original is, the negative square root. So I'm expecting the bottom piece of a parabola that's on its side, and I can figure out by looking at this equation that the vertex is 2, 6. Hopefully you got that. So 2, 6, right about there. And we already said the negative piece, so we know that's the piece we're talking about. So if I take 2, 6 and flip it, that becomes 6, 2. Right there. And I had the negative piece of the original, so I'm going to have the negative piece, or the left-hand side of the parabola. So that's going to be this. Again, like I said before, negative becomes negative, positive becomes positive. That's easy to remember. So if I have the bottom part of the parabola on its side, I'm going to have the left piece of the parabola. So this is going to be, this was my original h of x right there, and this is my h inverse of x right there. So I can see that that is going to be just part of a parabola, which means once I solve this algebraically, I am going to have to restrict the domain because with this negative in front of the square root, the range of the original was restricted, which means the domain of the inverse is going to be restricted. So here we go. Y equals, we're going to go ahead and subtract 6. We're going to, well, there's two different things you could do here. You could either get rid of the negative first and then square, or you could just square, because when we square a negative, that negative goes away. So either's fine. I'm going to go ahead and just get rid of the negative first. So negative y plus 6 is equal to the square root of x minus 2. And now I'm going to go ahead and square. And then when I square root, just what was underneath. And this, I'm not bothering to square. I'm going to leave it as negative y plus 6, the quantity squared. I'm going to add 2. And I'm going to interchange x and y and make this h inverse of x. So negative x plus 6 squared plus 2. So now that's my parabola's equation. But I'm, again, looking at my sketch, and I know that I don't want the full parabola. So I'm going to have to restrict the domain. So let's decide how. So I'm looking at the vertex, which is at 6, 2. And I know that I want to be at that point or to the left. So 6 is the x value. So it's going to equal 6, or to the left would be less than. So x is less than or equal to 6 is my domain restriction. Now my graph and my inverse equation match, and I'm finished. Last one, part D. So we have y equals negative 3 times the quantity x minus 6 squared plus 4. We're going to start with a sketch. So we can see that this equation is going to be a parabola, a full parabola. So let me go ahead and sketch that. And I know that 6, 4 is going to be the vertex, and it's an upside down parabola. Again, I'm not going to take time to make sure it's exactly stretched correctly or anything, because I'm just doing a sketch. So a full parabola that's upside down. When I flip that, I'm going to get a full parabola on its side. So we had 6, 4, so 4, 6. Right about there. And if I flip that across y equals x, I'm getting a full parabola on its side. So because I'm getting a full parabola on its side, I know that when I solve this equation and get the equation for the inverse, I do not have to bother with a domain or a range restriction. I'm just going to keep that equation. So I'll go ahead and get it. So subtract 4, divide by -3. So that's negative 1/3 y plus 4/3 equals x minus 6, the quantity squared, square root. Squaring a square root gives me the absolute value of x minus 6. So x minus 6 equals plus or minus the square root of negative 1/3 y plus 4/3. Add 6. And we have x, and this one was just y equals to begin with, so that is my inverse equation. I don't need a domain restriction because remember we started with a full parabola upside down. We ended with a full parabola on its side going to the left. The reason it's going to the left is the square root of a negative 1/3. Whoops, looks like I forgot to interchange my x and y. So let me just do that right here. So that's an x and that's a y. So y equals 6 plus or minus the square root of negative 1/3 x plus 4/3 is my final answer. But again, the negative 1/3 x, square root of that is what's causing it to be opening to the left rather than the normal way to the right. Okay, so we finished up all of page 5. For homework, you're going to do worksheet 5 problems 1 to 5 and 8, and you're going to do worksheet 6 problems 4 and 5. Do those for tomorrow.